Today we are working on solving special systems. Okay, so first thing, before we move on with this lesson, I do want to mention something. Something that I've noticed over the years of teaching these special systems is my students tend to do very well with systems, but all of a sudden when I introduce these special systems, which is basically going to be no solution and infinitely many solutions, all of a sudden they start to make a little bit more mistakes. So please keep that in mind as we're going over this lesson. Don't forget the stuff that you've already learned and how to check our solutions and whatnot. So our content objective is students will be able to solve systems of equations by substitution or elimination. So notice here we're not going to be working on graphing. In fact, we've already covered it in a few lessons back. Language objective is students will be able to justify why a solution to a system may be no solution or infinitely many solutions. So I really want you to work on justifying why are you claiming that it's no solution or why are you claiming that it's infinitely many solutions. Why am I learning this? Well, it's important for real life problems like when will two cars reach the same destination if they are driving at different rates and different starting points. So this is going to be some background knowledge way back into the beginning of the school year when we were covering equations. In a case here, when we ended up with a false statement, we would say that the answer was no solution. So just remember that. And in a case like this, when we end up with a true statement, we would say that the answer is infinitely many solutions. So what I'm trying to recall and what I'm trying to get you to remember is in the case where we have a false statement, our answer is going to be no solution. And in the case where there is a true statement, that's going to be infinitely many solutions. So just keep that in mind. Okay, so now when we're solving using elimination, what I'm going to show you here is a very, very common mistake that you're going to see. And this is what I'm a little bit worried about because you guys can do very well like you have been. When you see these, you might make a little tiny error. So just pay very close attention to this one. So in this case, what's going to happen is this one's actually already set up so that the equation can eliminate one of the variables. In fact, you'll see here that the x's automatically eliminate without me having to manipulate any of the two equations. So I would end up with 7y equals 0. Now here is where these special systems is going to create this issue, because a lot of students in the past would stop right here and for some strange reason they would claim that it's no solution. Now this is a very, very, very common mistake that I've seen over the years, and I want to make sure you don't fall for the same mistake. Here you hopefully recognize that you're not done. If you divide both sides by 7, you would realize, hey, y actually equals 0. So it's definitely not no solution. In fact, what you would have to do is continue to solve to figure out what x is. So please don't assume the second you see a 0 that it's going to be no solution. In fact, no solution has nothing to do with a variable equaling 0. In fact, no solution has to do with ending with a false statement. So again, your answer is going to be no solution if and only if you end up somewhere with a false statement as you are solving for the variable. So now taking a closer look into special systems. We are going to get into special systems if and only if we see variables getting eliminated. Okay, so that's going to be a big hint. So here, if variables eliminate and you end up with a false statement, okay, your answer is no solution. So quickly, let me give you some examples. 3 equals 4 is a false statement. 0 equals -2 is a false statement. So all of these would give me the idea that it's going to be no solution. So here, an example like this, you'll see the x's eliminate and the y's eliminate. So you're seeing variables get eliminated, and you also recognize, hey, look, that is a false statement. So those are the things that you're going to be looking for whenever you claim it's no solution. Now, what if you have a true statement? Okay, then your answer is going to be infinitely many solutions. Some examples might be 5 equals 5 or 0 equals 0. So notice, even as these zeros pop up, That's no indication of why the answer is no solution. To me, all I care about is, hey, did any variables eliminate? So let's take a look at an example like this. Here, the x's eliminate and the y's eliminate, okay? And guess what? From that, we did end up with a true statement. And because it's a true statement, that's why we would claim it's infinitely many solutions. So again, before you make any of these special systems, you claim that it's no solution or infinitely many solutions, check to see, hey, did any variables eliminate? And if so, did we end up with any false statements or true statements? Okay, with that said, let's go ahead and jump into our first example. For number 1, I recognize, hey, both of these equations are in standard form. I think the best choice is going to probably use elimination. So in order to eliminate one of the variables, I'm going to aim for eliminating the x. So I'm going to go ahead and change this first equation by multiplying it by a positive 2. That's going to leave me with 4x, because 2 times 2x is 4x. 2 times negative 4y is negative 8y, equals 2 times 3, which is 6. Now for the second equation, I'm going to keep it exactly the way that it is. In a case like this, I'm going to notice something. Hey, look, the x's eliminate each other, the y's eliminate each other, so I'm only left with a 0 on this side. And here, 6 minus 6 is 0. So because variables were eliminated, okay, I'm automatically thinking there's a good chance it's no solution or infinitely many solution. But before I can claim that, I need to check, do I have any true statements? Do I end up with a false statement? The answer is yes. Here, I end up with a true statement. And because it's a true statement, I would go ahead and say that the answer is infinitely many solutions. Now, again, a very common mistake is students are going to see 0 and try to say that it's no solution. If you do claim it's no solution, you should be checking, hey, did you end up with a false statement? If the answer is no, then your claim is incorrect. So please be very careful about making that statement. So here, I am going to be asking you to check. Well, how do you check? Number 1, you're going to check that variables indeed got eliminated. So if you see that, just simply circle that and say, hey, look, variables were eliminated. And the other thing you're going to check for is, if you're saying it's infinitely many solutions, you need to prove to me by circling the true statement. So here I would circle, hey, look, I do have a true statement, and that's how I came to this conclusion. So please make sure you have that checklist and show that, hey, I'm pretty sure it's this answer because of these reasons. You're justifying. Okay, on that note, what I'm going to have you do is go ahead and pause the video and try number 2 on your own. Okay, so trying number 2. Number 2, I'm seeing that I could use substitution. However, by substituting, if I divide everything by 4, I would actually end up with fractions, which is definitely not favorable for me. So it would be a better idea to go ahead and turn it both into standard form, so I can go ahead and use elimination. So the first equation is going to remain the same. However, the second equation is going to change. So since the first equation is going to stay the same, I'm just going to rewrite it. Since the second equation is changing, I need to get it into standard form by moving 2x over to from the right over to the left by subtracting 2x from both sides, leaving me with a negative 2x plus 4y equals 8. At this stage, they're both in standard form, which is exactly what I want. However, none of the variables eliminate, so I'm going to have to manipulate maybe one or both. In this case, I would only have to change the first equation by multiplying it by a negative 2. If you're wondering why I multiplied by a negative 2, is because here you'll see that we have a negative x and a negative 2x. Unfortunately, 2 negatives isn't going to allow me to eliminate the term. So in order to do that, I would have to make one of them a positive, and that's why I went ahead and multiplied by a negative 2. So once you distribute to every single term, this would leave you with a positive 2x minus 4y minus 6. Sorry, equals negative 6. The second equation is going to stay exactly the same. Now you're going to notice here, look, the x's canceled each other out, the y's canceled each other out. So I'm basically left with a 0 on the left side, leaving me with 0 equals 2. So because already I'm witnessing, I notice variables are getting eliminated. I'm going to keep in mind, hey, if I end up with a true statement or a false statement, it's going to be either no solution or infinitely many. In this case, since it is a false statement, I'm going to go ahead and say that it's no solution. But again, how do you check? Well, number one, show me that somewhere variables were eliminated. So in this case, I'm going to recognize, hey, look, the x's got eliminated and the y's got eliminated. But then most importantly, especially with no solution, you better show me where you end up with a false statement. So here I would circle, hey, 0 doesn't equal 2. There's my false statement. Okay? So please understand, 0 has nothing to do with no solution. No solution is your answer if and only if you end up with a false statement as you're checking as you are doing the work. Okay, so now let's take a look at another example. For number 3, hopefully you recognize in this case, since it's already set up as y equals, substitution is probably going to be your best bet. So here I'm going to go ahead and write y equals 4x. So I can go ahead and take this 4x and plug it into y into the other equation. So I'm going to write 12x minus 3y equals 3. So I'm going to take this 4x and substitute it in for y. So here we have 12x minus 3 times 4x for y equals 3. So here we have 12x. Negative 3 times 4x is a negative 12x. Negative 12x minus 12x is 0. So here, because it's a false statement, I'm going to go ahead and say that the answer is no solution. But again, you need to check your work. How am I going to check my work? Well, number one, I need to illustrate where the variables eliminated. I would say, hey, look, the variables were eliminated right here. 12x minus 12x is gone. What else do I need to prove? Well, I need to prove that I had a false statement, so here it was. 0 does not equal 3. So I'm going to go ahead and claim that that is my false statement. So this is going to help you make sure you don't accidentally say no solution when you're not supposed to. So please make sure you identify where the variables were eliminated. So notice not both of them have to, especially with substitution, you're only going to see it once. Okay. With elimination, you should see it happen to both variables. So just keep that in mind. Okay. So now I want you to go ahead and pause the video and try number 4 on your own. Okay, so for number 4, again, hopefully you recognize substitution is going to be probably your best bet. So here, I'm going to write y equals negative 3x minus 1. Why am I using substitution? Because y is already solved for, so I could take this expression and substitute it into the other equation, which is negative 9x minus 3y equals 3. I'm going to go ahead and take this expression and substitute it in for y. How come I substitute it in for y? Because here it says y equals. So now I'm going to have negative 9x minus 3 times the quantity, negative 3x minus 1, and it's supposed to equal 3. At this point in time, I would have to go ahead and distribute. So this is plus 9x plus 3 equals 3. Now here, you're going to recognize, hopefully, that a negative 9x and a 9x is going to be 0. So essentially, they eliminated, and you end up with 3 equals 3. So here, because I ended up with a true statement, I'm going to go ahead and say that it's infinitely many solutions. But again, I need to check my work by first saying, okay, here, the variables were eliminated, so I'm just going to go ahead, let's use a different color. Here, the variables were eliminated, okay? And then the second thing I would have to check is, hey, look, this is where I have a true statement. So in your work, even identify it and make sure it actually happened. that again, your variable is eliminated, and you end up with a true or false statement depending on your answer. So that's it. Hopefully you got the correct answer. So now let's go ahead and move on to the next type. Okay, let's go ahead and do number 5 together. For number 5, I'm thinking to use elimination. Why? Because both of them are already in standard form, which is really nice. And it's going to be pretty easy to go ahead and eliminate the x's because they're already the same number. I just need to make one of them a positive 8. So in that case, I'm choosing to change the second one so that I can keep all my numbers positive, and you'll see in a moment how that works. First equation is going to remain the same, negative 8x plus 9y equals 8. Here we're going to end up with 8x plus 7y equals negative 8. Here you're going to see that the x's cancel each other out. So in my mind I'm thinking, let's see if I end up with a special case. And again, I either end up with a true statement or false statement. So here I'm going to have 9y plus 7y is 16y equals 0. So again, should I say this is no solution? Absolutely not. Why? Because I don't have a false statement anywhere. So I'm just going to keep working and go ahead and divide both sides by a 16, which leaves me with y equals 0. So this is definitely not no solution. I already have part of my answer. Now that I know what y is, I'm going to go ahead and substitute it into one of the original equations. So let's use the second one, negative 8x minus 7y equals 8. I'm going to take 0 for y and substitute in for y. So we have negative 8x minus 7 times 0 equals 8. So here we have negative 8x equals 8. Divide both sides by negative 8. And I'm left with x equals negative 1. So here I'm going to say that I think the answer is negative 1 comma 0. So notice, just because we've been practicing infinitely many solutions and no solution, don't assume every single answer now is going to be those, one or the other. Don't forget the types that we've been practicing for a very long time. So at this stage, I need to go ahead and check to see if this answer does work for both equations. So let's do that. Here the x's are negative 1s and the y's are 0s. So here negative 8 times negative 1 plus 9 times 0 equals 8. Is this true? Well, 8 plus 0 equals 8. This is true. So now all I need to do is check the second one. Negative 8 times negative 1 minus 7 times 0 equals 8. Here we have 8 minus 0 equals 8. This is definitely true, so I can confidently say the solution for this system is negative 1 comma 0. Okay, with that said, go ahead and try number 6 on your own. Okay, so let's check out number 6. Number 6 here, I'm going to actually show you both ways because some students may think elimination is easier and some students may think substitution is easier. So I'm going to go ahead and show you both. In this case, if I used elimination, all I would have to do is go ahead and change the second equation by multiplying it by a 2. Okay, and by doing that, I would end up with the first one staying exactly the same, but the second one would change to 2x minus 4y equals 4. In a case like this, I'm going to see, hey, the x's cancel each other out. The y's also canceled each other out, leaving me with 0 on the left side. So we end up with 0 equals 6. So because I ended up with a false statement, I'm going to say that the answer is no solution. Not because I see a 0 anywhere, but because I see that I ended up with a false statement. So how do I check this? Well, first I need to see that variables eliminate. Yes, I see it here and I see it here. In fact, when you're using elimination, you should see both variables get eliminated. Okay, so here the variables got eliminated, and next I need to show where did I end up with a false statement. Here you go. 0 does not equal 6, check. So please, once again, check to make sure that this is there to prove that your answer is no solution. Now, some of you may have felt more comfortable with substitution, so I will show you that one as well. For substitution, you would go ahead and isolate x because that's going to be your easiest variable to isolate. So in this case, add 2y to both sides, and then I end up with x equals 2y plus 2. Now all you would have to do is take this value of 2y plus 2 and substitute it in for x. So now you have negative 2 times 2y plus 2 plus 4y equals 2, leaving you with negative 4y minus 4 plus 4y equals 2. Combine like terms. Oh look, a negative 4y and a positive 4y gives me 4y. Essentially that means they were eliminated, leaving me with just negative 4 equals 2. This is a false statement. Because I ended up with a false statement, I'm going to go ahead and say it's no solution. So here, how do I check? Did variables eliminate? Yes, right here. Okay, or you can even claim it here. It really doesn't matter. You're showing that there's no more y's. And next, where's your false statement? Right here. So please don't forget to show those things. This is your way of checking your work. Okay, it's actually easier because it's just a matter of circling where it occurred. Okay, so that's going to actually conclude the lesson for today. Thank you so much for tuning in, and as always, until next time, bye.